Hi everybody, I'm happy to be here for this first edition of the RGB Game Programming Conference to talk about last night game architecture and more especially how we try to empower designers to create a small, dense, simulated open world. My name is Nicolas, Gatsmith on social networks, and I'm working for Hotels since 2018 on the first video game of the company, still in production last night. So we are a small company of 4 people, four full-time people, working on the last night. So some of you may have heard about the project following a presentation, a trailer presented during the E3 2017. And to be sure that everybody here has an idea about what the games looks like, let's play the trailer right now. So, as I said, we are a small team. The studio is now fully independent, no publisher. And we are led by a strong vision. First, an artistic direction. I can go, no. Yeah, an artistic direction. That's obviously what stands out the most when you watch the trailer. A mix between 2D pixel art and 3D cinematography with state-of-the-art volumetric lighting, dynamic weather, and more. But Last Night is not only about visual, it's also a game design direction. An immersive narrative experience in a small, dense, open world. Wake up, explore, discover places and events, eat and drink, talk, meet, make choices. A set of characters and situations designed to explore a potential future of our civilization. This to encourage the player to imagine a potential future with things we could have succeed or failed without judgment, and maybe try to think about some philosophical or ethical questions. And to bring this to life, we needed technical direction. We wanted everything to be animated, dynamic, simulated, and reactive. The weather, for example, the wind, the rain, the fog, the thunder, all of that are variables, in other words, values evolving over time. And we wanted to have a lot of elements in the game to react to those values. The environment can become wet. The wind can create ripples on the water. The sounds of the rain, or maybe characters taking out their umbrellas. So how do we tackle this challenge? Can we create an evolving, interconnected, dense open world, but without AAA firepower? In Unity, which is unfortunately not well known for facilitating open world creation. In a completely new visual style, and seamlessly mixing systemic simulation with uncrafted situations. So for the story, back in 2017, Team Survey, the creator of Hotels and the Last Night, was struggling with the game architecture. They had already tried some different solutions, including things like dependency injection, but for this project it wasn't satisfying because they really wanted something easy to use, something flexible that would allow not only the programmers but the whole team to create the logic of the game, the contents of the game. Ideally, the programmer should focus more on the systems implementing the features. So they also wanted a solution with less, requiring as less as possible technical knowledge. So when I joined the company in 2018, that was my main objective, to set up the whole game architecture. So what did we end up with? The initial inspiration of the architecture I'm gonna showcase was a famous unit talk by Ryan Hippel, where he explained how to take advantage of Unity scriptable objects to create a powerful game architecture. So we took that and we tried to push it further and adapt some concept to our needs. I need to mention that what I'm gonna showcase is a result of years of research and development and is, as any solution or tool, not a perfect fit for any type of game. So it was what we needed for the Last Night, what we wanted. So the first step was to create a viable system with the objective of having a high flexibility architecture. Usually, the programmers are the ones who are creating the variables in the scripts, and then they can let designers use tools like the Unity editor or the Unity inspector to modify the values of those variables. Let's take a basic example, like if you want to connect an audio source volume to the rain intensity of a game. So you want to define the audio source volume based on the rain intensity. No rain, no sound. So the script could look like this. You need to reference the weather system to get the rain intensity. You need to reference the audio source volume, the audio source, to know which audio element you want to modify the volume. And then maybe in each frame, you can inject the rain intensity into your audio source volume. And then you take advantage of the Unity inspector, so the designer can add the script as a component when they need it. They can reference the weather system, they can reference the audio element, and voila. But if your weather system is in, for example, another scene, you already have a problem because, as you may know, Unity doesn't support cross-scene references. And what if you want, instead to use the rain intensity, you want to use the wind speed? You need to modify the script or create a new one. So designer needs to ask a programmer to do changes. So you end up with something with high dependencies and low flexibility. And if you continue like that, the problem keeps growing. Every piece of code depends on the others. Nothing works in isolation. It's hard to debug. It's not scalable. It's a nightmare, a spaghetti nightmare. So with our viable system, we can avoid some limitation. Instead of saying, OK, we need the rain intensity, we can say, I need a float value without knowing from where the value is coming from. And we can use this value to do what we want. In this case, modify the audio source volume. And then, again, we take advantage of the Unity editor, the Unity inspector, to define here where the value is coming from. So it can be a local value, the same way as if we used a simple float in the script, but it can be a component variable. So a component we add in our scene to create a new variable, which can be referenced by any elements in the scene. And if we need a bigger scope, it can be a scriptable variable. So for those who are not familiar with Unity, a scriptable object is a very powerful feature of Unity. It's files, assets, which are living in your project, and they can be referenced from anywhere, from any scene, from any prefab. For example, or for the weather, the rain, intensity, etc., all of that is scriptable variables because we need those values to be accessible from anywhere in our game, in our open world. So with a proper setting, we can fall back to our initial example. Maybe I can create a component variable if I want to use it, or I can drag and drop the rain scriptable variable in the field to use the rain. And now if I want to use the current thunder value or the wind speed, I just drag and drop the value and it's working. So we have something much more flexible and with lower dependency. But we can go one step further, introducing what I named modifiers. Modifier is a way to define values using predefined configurations. So on the slide, you can see all the existing modifiers for float variables. And it's a way to define all the value, what's the value. It can be the result of a float operation, addition, subtraction, whatever. It can be a random value, it can be mathematical values, a Perlin noise value, a sinus value, a p constant, whatever. It can also be a value coming from another component. So using the float from light modifier, we can get the light intensity and inject it into our audio source volume. And now when I modify the light intensity, I see that the audio source volume is changing too. And modifiers are very, very powerful because they can be combined. So for example, I could use a float from transform modifier to get a transform and use the exposition of a transform as the value. And this transform it's a transform reference. So it can be a local transform, but it can be a component transform or a value coming from a transform scriptable variable. Or it can be defined itself through another modifier. So we could use the transform from main camera modifier, and now we get the main camera transform. And that's how you can inject the exposition of the main camera transform into your audio source volume. Of course, this example doesn't make really sense, but just to show you how much flexible it can be. So that's the core pillars of the variable architecture, but we can go, again, one step further. Now that we have modifiers, why would we limit our script to only set an audio source volume? Instead, it could set a float value. So we inject any float value into any float value, and we let the designers be creative with it. Using the proper setups, we can fall back to our initial example, using the rain scriptable variable and using a float from audio source modifier to modify the audio source volume. But now, we can do something totally different. We could use a random value as an input, and for the target, we could have the light intensity. And now, you have a light with a random intensity over time. And this is something totally different, and with the same script, which is only 10 lines of code. So it's very, very flexible and powerful. On top of that, we have some additional features. I can't go into all the details, so I'm just gonna show a few very quickly. We have the variable propagation changes. Any code, any logic is able to listen a variable reference to be notified when the value has changed. In our simulated open world, it's something we use a lot. It's a way to lean towards what we call reactive programming by considering value change as events. It's also a good way to simplify the code, because sometimes it means you don't have to each time cache the previous value, compare the previous value with a new one, and if it's different, to update the previous value to execute some logic, etc. We just listen the variable, and that's all. And this means it's easy to create logic that is not executing every frame when it's not needed. So it can be interesting for optimization. So if we take our initial script, we can just modify a little bit to execute the logic, not every frame, but only when the input value has changed. So we listen the input value. And when the value changes, we update the target value. We also have some blackboards, which is basically a way to define a set of variables and keep things properly organized. We have cross-scene variable support, so you can as I said, something which is not initially supported by Unity. Sometimes you want a variable to be accessible from multiple scenes without necessarily wanting to create a scriptable object variable, because scriptable object, as anything, has some limitations, some issues, like the way it's loaded in memory. So we absolutely don't want to use only scriptable object for any variables. So you can create a float crossing or a cross-scene variable in a scene, and using the cross-scene modifier, another scene, in another scene, you can drag and drop this cross-scene reference, and in the backend, it's using a GUID system to recreate the reference in runtime. Our saving system is also taking advantage of the variable architecture, because when we save the game, we just save the variables we want. And when we load the game, we just update the variable value, and we let the elements of the game update their simulation state. So for example, let's say we have 100 buildings in our city, or 100 shops. And to make it simple, those shops can open or close, and all of those shops are opening or closing based on the time of the day. So instead of saving the simulation state of each shop, we could just save the time of the day value. And when we load the game, we load the variable, we load the time of day will be updated using the saved value, and we let each shop updating its own simulation state. And so that's the first pillar of the architecture, variable system. It's very powerful for value bindings, connect things, but how do we handle more complex things like conditional or branching logic? Because even if the last night is a simulated open world, it doesn't really rely on systemic gameplay. We script a lot of things inside our simulation to make things interesting and to stage the narrative. So we wanted to allow any team member, any designer, whatever, to create some logic without coding. In other words, a visual scripting system. Allowing the artists, the writers, even the sound designers to create their own logic can be very useful, because they can inject their own sensitivities, their expertise. As a programmer, I don't trust myself to play a specific sound with a perfect timing, with a perfect mixing settings. I prefer, when it's possible, I prefer to let the sound designer do it himself. And so that's how I created our own visual scripting system. So in this slide, in this example, I'm recreating the previous example. I can, in a game object, in the scene, I can create a graph. I can open the graph, and I can start creating my logic. So first, I need to add a node to define when the logic is going to be executed, an event node. So in my case, when a float value change, which value I drag and drop the rain intensity scriptable variable. And what I want to do after is just to update a float value. I use the proper modifier to reference the audio source volume, and I say, okay, what is the new value? It's the new rain value. And so we have the same thing as before. We can see that I can enable a rain in edit mode support, and when I modify the rain intensity value, we can see the graph executing and the audio source volume updating. Of course, we could have used existing solution. At that time, there was Bolt, a famous Unity plugin for visual scripting, which has been acquired by Unity in 2020 and is now fully integrated in the editor for free under the name of Unity Visual Scripting. But we really wanted something that would take advantage. So it wasn't the case. First, it wasn't the case at that time when I started creating the whole architecture. Bolt wasn't yet acquired by Unity. We also wanted something that would take advantage of our variable architecture and something on which we would have full control. More than that, I think personally that Unity Visual Scripting has some big issues. For example, if we take a basic example, like when you press space on your keyboard, you want to increment a float value. With Bolt, it's already 4 nodes, whereas with our solution, it's only 2 nodes. And it's well known that it's well known that the more we have nodes in a graph, the more it's difficult to understand what happened. And yeah, so I let you imagine how much difference it can be when you have complex graph with dozens of nodes, if you need twice the number of nodes with Unity Visual Scripting. More than that, I think it's much easier to understand what happens just by reading the titles of our nodes. On keyboard space up, increment my variable by 1. It's pretty straightforward. Of course, Unity Visual Scripting has its own variable system, but it's using weak string references. So it means that as soon as you rename a variable, it breaks all the existing references to it, which is crazy. It's terrible. No way we want that in our production. You know that making games is already very difficult. We don't want to have such chaotic things in our production to make a game as complex as The Last Night. No way. It's also interesting to have a look at the performances. What happens if we execute the previous logic 100,000 times? So just incrementing a float value. First, with C#, we have 10 milliseconds of processing. Important precision. It's not incrementing a simple float, but a float component variable, so that the comparison, we have an equivalent comparison with what we are going to do with Visual Scripting, and equivalent in terms of features. So 10 milliseconds almost with C# and 0 memory allocation, of course. What happens with Unity Visual Scripting? We have almost 700 milliseconds, which is 70 times slower than C#. And we also get 11 megabytes of allocation. So it means that if your game is running at 60 FPS and you have 1 execution per frame, you will have 100,000 execution every 28 minutes. So it means that every half hour you have 11 megabytes of allocation. Okay, but don't forget that it's a very basic logic, very simple, just incrementing a float. We could totally have that on a prefab, and with a prefab instanced 100 times in your scene. And now, in this situation, what we get is that you have 100 execution per frame, and it's no longer 11 megabytes every half hour, it's 1 gigabyte allocation every half hour, which can put a lot of pressure on the memory garbage collector. So what do we get with our solution? With our solution, we have almost 50 milliseconds of processing. So it's 5 times slower than C#, but it's 14 times faster than Unity Visual Scripting. Of course, it can depend on the logic created, the examples, but I think it's safe to say that our solution is at least 6 or 7 times faster than Unity solution. And more importantly, I think, is we have 0 memory allocation, because all the potential memory allocation are cached and reused. So in the long run, you don't have any memory allocation. And regarding the performances, it's the result of using interfaces instead of reflection. There is no reflection in our solution. So for all those reasons, not only the performances, but what I mentioned in the previous slide, creating our own visual scripting system was sure a big investment, but I think on the long run, it was worth it. Of course, we are not using visual scripting for everything. There are things where we prefer to use C#. So for systemic features, we use C# to have something reliable and performant, and even sometimes taking advantage of C# jobs or burst when it's possible. So for example, player controls, crowd systems, pathfinding, all of that is done in C#. But when we have things that we want to be able to customize on a case-by-case basis, then we take advantage of the visual scripting flexibility to create uncrafted things. For value bindings, as we saw before, for the interactions, to define, okay, what happens when I interact with this element, triggers, etc. So we need to be careful because if we are not careful, we can easily end up with something like something totally out of control with tons of variables and connection in all the directions. So the same way as in code, we need to be careful and to have to try to follow some principles to keep things organized. The same way that in code you wouldn't want to have only static global variables, in our system you wouldn't want to have only scriptable variables, and try to minimize the scope of the variables. We can also combine scripting and visual scripting. Let's take a basic example with the doors. We have a lot of different types of doors in our game. We have rotating doors, sliding doors, manual doors, automatic doors, single doors, double doors, etc., etc. How do we handle that? Every common features between all the doors can be put in a C# door script. It can be seen as a door API. But that API has no idea about when the door should open or close, or when or how the door should close. The script only contains really some systemic features. It could be, for example, to ensure that a door is never closing if there is a blocking element inside the area, like a character. The when are defined, when the door should open or close is defined in external logic triggers. It can be player actions, entering a code on a keypad, character detection for automatic doors, but also a button in the inspector for debugging. And on the other side, the how the door is opening or closing is defined by visual scripting. Animation, sounds, lighting, all of that is using flexibility, is taking advantage of visual scripting flexibility. Of course, the door C# script is able to know when the linked visual scripting logic has finished to know exactly when the door can be considered as opened or closed. So concretely, this allows us to have something very decoupled and working with things working independently, and to use the same door C# script for all the types of doors, despite important change in how the door is animated or whatever. So if we take an example, we have a base prefab for the door, which contains all the common logic, so including the door C# script. And then we can create prefab variants for all the type of doors. So in this example, I created a blockout door, which is a prefab variant with some rotating logic in the visual scripting side, and we can have another prefab variant to have the double door, where the visual scripting is triggering an animation on the animator controller, on Unity animator controller. We can also, if we really need we can modify values on a per instances basis. So when we put some doors in our scenes, we can also modify some settings by overriding prefab values. Usually, what we do is that we create a component blackboard on the prefab, where we expose the settings that are likely to be modified per instances. Could be, for example, the rotation duration. So this allows in the scenes to easily modify what we want without having to dig and to open and dig into the complex, sometimes graph logic, visual scripting logic. And as I did for the variable architecture, we have many other features that I don't have time to talk about. So I'm just going to show a few very quickly again. We can create visual scripting logic directly inside animator controller states of Unity, which is very useful sometimes when we want to create more complex animation logic. And we have also debugging tools. And if I had to mention only one, it would be the variable monitoring system. So we can take any variable we created, and we can track the evolution of the value over time. So on the curve, we can see, I can click on the curve, and it can give me information about what was the previous value, what is the new value, and more importantly, what changed the value. What's the source of the change? It can come from, maybe we change the value in the inspector, but maybe it's a change coming from another script, or maybe from a specific visual scripting logic. So having this tool is very useful when we want to debug some elements in the scenes. In conclusion, basically we try to move the value bindings and contents logic from the editor, from the script, from the code to the editor. We try to have things decoupled, to decouple things and have architecture flexible and modular. we take advantage of, we let the designer create the logic of the game. Yeah, ideally, as I said, programmers should focus on creating the systems, implements features of the game, not creating the content like how the light is lighting on or off, etc. We have better iteration time because, as you may know, when you modify a script in Unity and you get back to the editor, you need to wait the end of the compilation and assembly, domain reload, assembly reload, and sometimes in big projects it's easily 20 seconds to wait, so it's not great. Whereas when you edit, when you modify a visual scripting logic, the changes are applied instantly. More than that, we can open any visual scripting graph. We can right-click on any node, and we can, in the menu, click execute. So we can trigger any logic easily to debug or test things. The same way, we can open any visual scripting graph. We can right-click on any node, and we can toggle some debugging options, like show me a console message, or pause the game each time this specific node is executed. So all of that makes debugging of the game easier. And that's all for this presentation. So thank you for your attention. If you want to follow the progress of the game, you can have a look at our website, hotels.net, or better, you can follow us. You can have a look at our Discord server. There are quite a few active members here with pretty interesting discussion, not only about games or last night, but also about cyberpunk, cinema, or photography. So don't hesitate to have a look. And if you want to follow us, you can follow Hotels at X, so on X at Hotel Games, or even myself, if you want, at Gatsmith on X. Thank you, and if you have any question, don't hesitate.
Does it work? Yeah, okay. Sorry, thank you for the presentation. How did you manage or did you actually manage the versioning of these visual scripts?
It's like usually like logic when you put logic in scene or script or on prefab, it's the same way. It's serialized directly.
Okay, so it serializes into a Unity-like object that you just
of
like
course,
this.
yeah.
But so it doesn't merge or anything easily.
Yeah, of course, it's like the scene of a prefab. If you have two people modifying the same scene or the same prefab, so the same visual scripting logic, you're
gonna have an issue.
Conflict. So we have tools to be able to lock files or lock scene, and this way I can see, okay, this one is all working on this element. If I open the prefab, I will get a message warning. Is editing it, so be careful, or in the scene. So we have tools to avoid merge conflict.
Okay.
But it's a problem you have with the same problem you have with scenes or prefabs.
Okay, thanks.
How do you handle cross-scene references? Where do you save the information?
Yeah, so when we create the cross-scene variable, it's assigning a GUID, so a unique identifier, which is serialized as a byte array. And on the other side, when you have a reference to a cross-scene, when you do the drag and drop in the editor, we save the GUID, and at runtime, each time a cross-scene variable is referenced, it's notifying a system. Okay, it's saying, okay, my GUID is this one, and I'm living here, and this is myself. And when you have a reference, you can ask the same system, okay, I need this GUID, and give me the reference. And if it's not loaded yet, you can ask, okay, notify me as soon as it's loaded. So we can also have cross-scene references, and now if the cross-scene reference, the cross-scene variable is loaded or not yet. Make sense?